Hi everyone. So again, I'm back with another new question. Okay, it was asked in GATE 2012 from the subject electromagnetic. Okay, and that is one of the prerequisite topic which we cover before we get started electromagnetics. That is vector calculus, right? So this topic was asked from divergence. Okay, so let's see how we are going to approach this question. This question is based on divergence. Okay, and you must know what is the what is divergence of in a vector in a spherical coordinate system, right? So this question seems very easy, right? So let's see this question. This question was asked for 2 marks in GATE 2012 ECE paper, right? And I always emphasize here that that year the topper marks was 67 out of 100. Okay, and in future I would also tell you the name of the topper, right? That topper was one of my very close senior, right? So still we are in touch, and okay, he's working in very great company. Okay, so let's talk about this solution, right? First of all, so GATE 2012 ECE paper, right? So let's read the question first. The direction of vector A is radially outward. See, this question can be done again within 10 seconds, right? But let me explain you, okay? Direction of vector A is radially outward from the origin, right? With mod of A is given as, so what is given here, you can note down. Mod of A is given as kr to the power n. Where r square is what? Where r square is basically x square plus y square plus z square. What is the trap here? Okay, and k is a constant, so you have to find the value of n, for which they have already told you that the divergence of a equal to 0. Okay, divergence of a equal to 0. What is mean? What does it mean? Divergence of vector is 0. It means that you have to understand this is kind of a solenoidal field. Okay, the okay, so they have already told you that divergence of a is going to be 0. Now, as far as this component is concerned, okay, this component, this is the mod of A is given, right? So this they have given R component, right? In spherical coordinate system, there is R, theta, and phi. So what they have given here is they have given the R component. Okay, if I write A vector, so A vector is given like this: A R to the power n, A R cap. Okay, this is what they have given. Okay, if you will take the magnitude of this, so mod of A cap R is going to be 1. That is unit vector. Right? So many people, what they do is they go for Cartesian coordinate system, because they have given here r square equal to x square plus y square plus z square. Okay, and that solution consume lot of time. So let's see what is the divergence of A in spherical coordinate system. Divergence of A in spherical coordinate system is what? Divergence of A in spherical coordinate system is basically, you have to only talk about what? You have to only talk about the R component. Okay, R component, because R component is given, the theta and phi component is gonna be 0. Okay, so here you can write dou by dou R. Okay, so what you have to do here is you have to multiply R square with R component, AR, you can see, right? And you have to divide R square here. This is the divergence of A in spherical coordinate system, right? What you have to do here is you have to multiply R square with R component. Okay, so the very first step. Okay, whenever the R component is given, okay, so what you have to do, you have to multiply R square with R component, then take the partial derivative. Okay, then divide 1 by r square. This is how we remember formula for divergence of A in spherical coordinate system, right? You don't have to write for phi theta and phi, because they are going to be 0, because they have given they haven't given the theta and phi component, right? Okay, so yes, so let's go and determine further. Okay, so this is r square and dou by dou r. Okay, most of the people, most of the aspirant, they make mistake like this: r square and r square get cancelled. Don't. Okay, because we are multiplying and then we are dividing, right? So you don't have to cancel. Yes, so r square and a r component is given, right? magnitude, that is k times of r to the power n. Okay, so further if you solve, this is going to be dou by dou r, and this k you can take now outside because this k is going to be constant, and this is n plus 2. I hope this makes sense for everyone, right? Now you can differentiate. You have to do partial differentiation here. So k upon r square, okay, k upon r square is basically, this will be n plus 2 r to the power n plus 1, because that is going to be n plus 2 minus 1. So this is what. Now you can take r square up, right? So further if you solve this, k n plus 2 r to the power n plus 1 minus 2. Okay, so this is going to be again n minus 1, right? K n plus 2 r to the power n minus, you know. Now what they are asking is, they are asking that if divergence of A is going to be 0, so what is the value of n? So here you can see this should be, for this divergence to be 0, so n plus 2 should be equal to 0, right? Okay, because r cannot be 0. R is given as what? Under root x square plus y square plus z square. Okay, so n plus 2 equal to 0, it means that n will be equal to minus 2. For this question, okay, for this question was very easy, right? For this question, the answer is going to be answer will be minus 2. Okay, so this was a question for gate 2012 and for 2 marks. So again, you can get answer within 10 seconds, right? So if you will follow my YouTube channel, and if you want to learn how to solve questions, so you can right away hit the subscribe button if you're new to this channel, right? And the branch like the electronics and communication, electrical engineering, instrumentation, computer science, all 4 branches can subscribe this YouTube channel, and they are going to get benefited. In fact, mechanical engineering and civil engineering also, because they will be getting a chance to learn mathematics from me. Okay, and I will highlight all the application in their main subject, right? Okay, so I hope this solution is helpful for everyone. Okay, so we'll meet in the next session with new question. Thank you.